Have you ever stared at a maze? You know, the kind on the back of a cereal box? Your eyes just kind of trace the path and boom, you've solved it. It's totally a visual thing. And we kind of assume that the smartest AIs out there would do the same, right? Well, what if I told you they've been trying to solve these visual puzzles by writing a book report on them? Yeah, it's weird. Let's get into it.
Okay, so take a look at this maze. For us, the plan is simple. We scan the whole thing, our brain automatically starts shutting down the dead ends, and we visualize that one correct route from start to finish. Our brain is literally thinking in pictures.
So, the million-dollar question is, how does a top-tier AI, a multimodal large language model, tackle the exact same problem? Does it also just, see the solution?
Well, not even close, and this slide just lays it out perfectly. While we're visualizing the path in one go, the standard AI approach is to generate this super long, step-by-step list of text commands. We're talking move left, move up, move right, move up. It's basically translating a picture puzzle into a language test.
And this whole text-based method, it really shines a light on what you could call AI's visual blind spot. It's this deep, fundamental limitation when you ask it to do something that's just naturally visual.
And this is what it actually spits out. I mean, look at that. It's just a string of letters. This isn't thinking visually. This is just crunching symbols, one after another. And as you can imagine, it's incredibly inefficient and super easy for it to make a mistake, especially if the puzzle gets even a little bit harder.
And that is the absolute heart of the problem. This text-centric way of thinking just hits a brick wall with what researchers call long-horizon visual problems. The more steps you add, the more likely the AI is to just get tangled up in its own words, totally losing the plot. But what if we could teach an AI to just stop writing and start drawing? So let's dive into a totally new way of doing things that lets an AI finally, truly, start thinking in pictures.
This quote from the research paper behind a new model called DiffThinker just says it all. Instead of turning a picture into text, they had this radical idea. What if we just keep the whole thing visual? What if the task is just take an image in and spit a new image out?
And here it is. This is the result. Look at that. It's the same maze, but this time, DiffThinker's answer isn't a bunch of text. It's the original image with the solution drawn right on top. I mean, it's just so intuitive. It's elegant. It's a completely different way for an AI to think.
Okay, so how in the world does it pull this off? How does an AI reason by painting with pixels instead of writing with words? Let's get into the mechanics.
This diagram really captures the huge shift. On the left, you've got your standard models. Image in, text out. In the middle, you have some that try to use image tools, but it's a clunky, multi-step mess. But then, down at the bottom, there's DiffThinker. It takes in the image, uses a special diffusion model, which is amazing at creating new images, to do the thinking, and then it just generates the solution image directly.
The researchers have a name for this, generative multimodal reasoning. And it's such a simple but powerful concept. Just reframe the whole problem. Stop trying to jam a square visual peg into a round text-based hole. Let the AI solve the problem in the language it was given, visuals.
Okay, so it's a really cool idea, right? But does it actually work any better? Let's take a look at the results, because this is where things get, well, pretty dramatic.
Get ready for this number. On a whole bunch of really tough visual tasks, DiffThinker showed an average performance boost of over 314% compared to GPT-5. Let me say that again, 314%. That's not just a step forward, that's a giant leap into a different stadium. And it's not a fluke. This chart shows you its performance across 7 totally different tasks. Planning, puzzles, you name it. That red line for DiffThinker is just consistently miles ahead of both GPT-5 and Gemini-3-Flash. It's an absolutely dominant performance.
Let's look at some real examples. On the left, DiffThinker tackles a Sudoku puzzle. Perfect. Flawless. On the right, you see Gemini-3-Flash's attempt. See all those errors highlighted in yellow? This visual generative approach is just so much better at keeping things logically consistent.
And it's the exact same story with this jigsaw puzzle. DiffThinker on the left just nails the spatial layout. Gemini on the right, not so much. It gets some key pieces totally wrong. Thinking in pictures clearly gives DiffThinker a huge advantage in understanding how things fit together in space.
So what does this all really mean for the future of AI and computer vision? I mean, this is bigger than just solving puzzles better. This is about changing the fundamental properties of how a machine can reason.
The researchers point out 4 main things that make this new way of thinking so powerful. It's more efficient, you can control it better, it can reason in parallel, and it can even work together with other AIs. Let's zoom in on that parallel reasoning part, because it's really cool.
Okay, check this out. Instead of figuring out one path step by step, DiffThinker explores a ton of possibilities all at the same time. You can see in the early steps, it's kind of trying out all these different routes. Then it just cuts away the ones that don't work and focuses in on the best solution. It's a much more holistic, big-picture way of thinking.
And then there's this collaborative part, which is just brilliant. On a really tough puzzle, Gemini-3-Flash gets a big fat 0. DiffThinker gets 80% right on its own. But here's the magic. If you let DiffThinker generate a few possible answers, and then ask Gemini to just pick the best one, their combined score jumps up to 84%. DiffThinker basically becomes this visual reasoning engine that makes other AIs smarter.
So when you boil it all down, the big takeaway is this. We've gone from an AI that just describes solutions to one that can actually see them. And that leaves us with a huge question. If an AI can now reason visually, completely skipping over language, what kinds of massive, real-world problems in science or engineering or even art is it going to solve next?